Hey, good morning and good afternoon, everybody. Thanks for joining us today on our latest live stream as we talk about building an automated OT asset inventory. For those that are joining on YouTube, feel free to use the chat section for any questions or comments that you might have. For those that are going to drop early or need to exit the stream, I welcome everybody to join us on the 21st of June for our first part of the OT Vulnerability Management Masterclass that Ralph will be giving. From here, I'll pass it over to Ralph.
Thanks, Braxton. Good morning or good afternoon, everybody. Welcome to this webinar on automated OT asset management, OT asset inventory. Today, we are going to start we will be foundational. We start with the very basics, and that would be the question, well, what is an OT asset inventory? It's certainly not the physical stuff that you have, like a warehouse inventory, but it's a documentation of that stuff, if you will, of your OT devices, of your networks, etc. And that's a very important distinction. That documentation, you should think about that as a model, as an artifact. Why is that so important? Because what you want to do is you want to be able to do analytics on that model, because those analytics will tell you if what you actually have is what you would like to have, and especially when it comes to configurations. So once that you have the visibility into your devices, the firmware versions, etc., then you will be in a much better position to actually make up your mind if that is what you want to see, and that is where OT asset management comes in. So the first thing is that you have an inventory, like a documentation, like a model of what that is, and then you don't need to even use sophisticated methodology, etc., because when you look at that inventory, you will right away see, oh man, this is unexpected. I didn't know that we had so many outdated software versions. Let's just say Windows XP as an example, or I didn't know how many PLCs we have on the enterprise network. So that will just come naturally. And then there will be other workflows that you want to impose based on that model that are basically related in two different fields. And this is what you can see on screen. So an OT asset inventory is foundational both for security use cases and for engineering use cases. Best example would be vulnerability management. You cannot do vulnerability management if you don't know what you have. Well, you have heard that 1,000 times, right? But then act on it, come on, because if you don't have an automated asset inventory, and we'll get to that in a couple of minutes, you won't be able to do your OT vulnerability management, since OT vulnerability management or your known vulnerabilities are associated with specific software versions that you are running. And if you don't know about those versions, and the simple thing would be Windows 7, for example, then you don't know about your cyber risk, and you don't know how to address or mitigate that cyber risk. Another example would be your disaster recovery. If you basically have no clue or only a vague idea what you have installed, all the various software products, etc., all the network addresses, then your disaster recovery will be very much impaired, because this information needs to be then collected on the fly after the matter had already hit the fan. Very similar when you look at on the right side of the screen in engineering, you will find several use cases that you simply cannot do without an accurate and complete OT asset inventory. And one example would be the processing of vendor product notifications, which is very important for engineers. So every now and then, the large automation vendors put out advisories, notifications, informing you of some flaws in their product. Like I think recently it was an issue with Studio 5000 from Rockwell that affected two distinct versions, and those versions could have a negative impact on your PLCs. And if you have a comprehensive OT asset inventory, figuring out where you would have affected installations is a matter of seconds. If you don't have such an inventory, well, then good luck. You might never find those affected installations, and therefore you cannot fix the issue before it turns into downtime. Obsolescence management is another use case. Well, if you have no idea where you might have products installed, think of PLCs, network switches, etc., that you cannot buy any longer from your vendors, then you actually run a risk as far as business continuity is concerned, because once any of these things break down, then you will have a hard time replacing it. You will have to replace it with a different make or model. So now that we know what an OT asset inventory is and what you need it for, how do you get one? And especially, how do you get one in an automated way? And this is super important here, because still today, many organizations think that they could build an OT asset inventory manually using something like Microsoft Excel as the tool of choice to record this information. And this is utter nonsense, because manually you will never, and I repeat, never be able to collect all the information that you need for the use cases that you see on screen. That is not going to happen. So if you think about all the firmware versions as an example, if you think about the network topologies that you need to keep an eye on, that is not going to fly. So in that respect, what you are told even today, how to build an OT asset inventory manually, that is nonsense. That is not going to work. One prominent example, I discovered that recently, is the SANS, what is it called? The ICS Cybersecurity Field Manual, volume 1, 2, 3, all in one book, where SANS teaches you how to build an OT as an inventory. And it looks like this. So they suggest that you use a laptop with at least a basic spreadsheet application. I think we can substitute that with Excel, to start cataloging and storing ICS asset information during a physical site walkthrough. And the software tools that you would use for that, what they suggest would be ARP, NetStat, and T-Shark. And I have to break it to you, that won't cut it. That doesn't work, because that will only give you a superficial view, a very limited view of some configuration items on your network, and that is not necessarily not nearly sufficient to address any of the use cases that we have looked at earlier. So manual doesn't work, besides the fact that, I mean, you would need an army of engineers to actually pull it off, and you don't have an army of engineers, right? Your engineers are overworked already. So how would you then do that? So let's drum roll, let's come to the interesting part of this webinar. I will show you how you can do it with the OT base, OT asset management system that we happen to sell. And what you're looking at here is the discovery piece of that software. I'll come to the overall software architecture in a couple of minutes. So this is the configuration UI for an OT-based discovery node, as we call it. And once that you have launched this application, you will see all your local networks already on that screen here in the upper left corner. You can also add remote networks that you can route into. And let me just give you an idea how that discovery works. So let me just, for this test network, I'm going to delete those two devices that are seen here already. Delete those devices. So we pretty much start from scratch here. And in that test network, I bring up the context menu and click on probe and refresh current network. And while this is running, I would like you to focus on the parameters here in the right pane, which allow you to fine-tune the discovery process. Okay, so what you see here is a variety of different protocols that you can select for the discovery. It starts with IT style protocols such as SNMP and WinRM, and down here you find more OT protocols such as Ethernet IP, Modbus, or Profinet. Okay, and then you can select all of those that you want to use in this network for the probing. And you could also make a couple of additional adjustments. You can use blockout lists, for example. You can blacklist IP device ranges if there are some devices in that network that you just don't want to see in your inventory. Well, that's fine. You can do that by creating such a blacklist. And so you can really fine tune your discovery process here. As you have guessed already, this is active discovery. Isn't that disruptive? Isn't that unsafe? Isn't that calling for disaster? Well, just think about it. If you are a proponent of that idea, you would also have to say, no, we cannot use RS links, because RS links also actively sends out Ethernet IP packets to identify all those devices on my network, all those PLCs, RTUs, actors, sensors, actuators. And so it's basically, from a technical perspective, it's the very same thing. So if you would do a Wireshark trace of the packets that OT-base sends out, you wouldn't be able to tell a difference to RS links or similar products such as Semantic Manager, TIA Portal, etc. And also, obviously, the endpoints, the PLCs, the RTUs, they couldn't tell the difference. They are just treating that as a legitimate request by the engineering software. And in the meantime, you can see our result table filling up here. So everything in green was already fully discovered, and that just took a couple of minutes. And now you can, without having put any effort into this, other than clicking the button, you can get additional information on those various devices. So for example, here we have a Siemens S7315. Once that I select any of these devices, you can see additional details here in the right pane. And that tells us about the version of that product, the serial number, the order number, and I could also check out the software or the firmware version that's running on here. Okay, so same for any other product here. Oh, by the way, let's also, for that Siemens PLC, what you see is that there is a plus sign before that entry. That means I can open that up and check out additional information. In this case, it's the I/O modules on the backplane, starting with the rack itself, the universal rack. So the Siemens engineers will know right away what that means, and then we have the CPU. We have a communications processor and an I/O. And there's another plus sign that tells us, well, there is actually another bus behind that PLC. That's a profile bus. And we can drill down into that also and we see what's on that profile bus. Same thing if you look at Rockwell devices. So here, let's just go to general again. Here we have identified a Rockwell rack, and we can open that up in the same fashion. We see the I/O modules on the back plane, like so. Then we see, oh, there is a control net behind that. And there is also a device net behind that, and circuits and so on. So a plethora of details that if you wanted to collect them manually, well, good luck with that. I mean, that would already cost you a couple of hours. And all of that is now available for OT-based discovery and also for you to inspect. However, you would not inspect this or use this in this particular application. So this is just the configuration UI for the discovery process, which in reality is a Windows service that's running autonomously behind the scenes. This is, you do this only for configuring that particular discovery node and checking that everything is discovered properly, that all your configuration settings are okay. And once that you have done that, the software runs autonomously. It wakes up every 24 hours and does what you have just seen. That run that just takes a couple of minutes for a typical OT network, does it autonomously and then sends the results to a central database that in our case is on premise. So you will have that central instance, what we call OT-based inventory, that is not in the cloud, it's in your data center. And the other thing that I want you to focus on is, why is that necessary to upload it to a global inventory? Well, because if you go back to the various use cases that you want to address, this doesn't make a lot of sense if you do it for one network or even for one site. So many of those use cases, especially OT security, the vulnerability management, etc., disaster recovery, incident response, that makes so much sense, or you will be so much more efficient if you approach that on a global scale. So that brings us to the architecture. But before I go to the product architecture, let me point one thing out. If this has raised your curiosity, this application, you can actually download it from our website for free and check it out. So if you just want to get an idea how this automatic active discovery works, what it discovers, what it does not discover, download it from our website. Again, it's a Windows service with this UI, and you will need a Windows 7 box or higher to install it and run it. So let's look at the architecture. This is what you see here. You would deploy that discovery piece in your process networks. Like right in the various subnets, and the important thing here is behind your firewalls or DMZs or whatever you might have, because this global instance OT-based inventory that we will look at in a couple of minutes should never have the chance, the technical means to actually reach down into your process networks. That would be a severe security flaw, and we have seen such a thing with the SolarWinds disaster. When you remember all the various DoD sites that had been compromised because in that attack with SolarWinds, the architecture simply not just allowed to reach down to the endpoints, but also that was like a normal thing. And in OT base, we did it the other way around. So discovery runs autonomously and then automatically pushes the discovery results to OT base inventory, where it is then consolidated. So you don't need to digest all this detailed information up here right now, so we might go back to that later. You should just take away the idea, well, so this is a secure transfer of your data, and here is your global asset store, if you will, right? And this is where the data is consolidated. And what that means, you're going to see in a couple of minutes, well, because what we have seen so far in OT-based discovery, well, yeah, that already looks quite nice, but I would like to see more, and that could be, for example, the known vulnerabilities that come with these products and with the product versions that you have installed. And this is what OT-based inventory adds to the table. So here, basically, you have in discovery, you have the basic technical details. And the only thing that you would want to do as far as a manual enrichment is concerned is to tell OT base, well, this is from this location, this is where you have the opportunity to input a location ID or location tag, if you will, that references the physical location of that network where you did the discovery. And if you wanted to, you could even get much more granular. So for example, you could tell OT base, well, this particular RTU here, I even know the control system cabinet where this sits, and you would then put an appropriate location ID in here. And then, as you will see in a couple of minutes, you can match that to a fully fledged location tree in OT-based inventory. Okay, so back to our architecture. Here, this is where you have all the user access in OT-based inventory, and this is where we also take care of access control and also about all the integrations and enrichments. Let's take a look at that. So in our OT-based inventory, we log on via the web browser, and let's just set the scope here. Oh, by the way, what I'm looking at by default is the global inventory of all the devices that I'm allowed to see. But for practical purposes, you can limit that in the scope selection up here to a specific site as an example, or to parts of that site, to a specific building, room, or cabinet, okay? And then I can also just expose a couple of statistics, if you will, that give me an idea about that particular universe that I'm looking at. So what I would like to show you is, and by the way, every row here in that table represents one device, as we had already seen it in Discovery. And what I would like to show you is how the data that you have seen in Discovery turns out in OT-based inventory, because now, remember, this is where all the consolidation comes together. So you will see a lot of additional data. Let's check this out. But before we go there, let me also highlight a couple of things, how you can slice this inventory here. So for example, if I only wanted to see specific device types, such as switches, I just type in here in that filter field, well, I only want to see L2 switches, and then the list is shrink down to those devices in real time as you type. Or if I only wanted to see devices that run the Microsoft Windows operating system, then I could do it like that. Or only devices running Windows XP, just like that. Okay, so let's look at individual devices with all the consolidation going on. And what I would like to show you first is, let me just figure out this device. The PLC, let's take this one. And if I want to see the details, I just do a double click. And now let's see how this device looks like. So it starts with the when was the device last seen, what's its stage. This is the description, and this is maybe the second piece of information that you would want to put in manually. You want to tell users what this device actually does, what the function of it is. So this PLC, as the description tells us, this is for the underbody station 60. We can see that it's associated with an OT system. And here you see the location of the device that I mentioned earlier. And that location is shown as a hierarchy, and also in this case with a floor map, if somebody bothered to put that floor map into OT base, where the specific subpart is exposed here with this hotspot. So this is in a specific section of a building, very easy to model in OT base. The major thing that you need to do is you need to tag those networks or devices, as I've shown you earlier in OT-based discovery, with the ID or with a reference for that location. And then in OT-based inventory, you can build out your location tree and do the mapping. And what you then get as a result is what you can see here. The other thing that you see here, the vendor, the model, this is discovered automatically. This comes from OT-based discovery right away. Also the type PLC, that is discovered right away automatically. And now it gets interesting. The life cycle phase of this product. Oh, that's active. That tells us this product is still in active production by Rockwell. You can still buy it. So this is assigned automatically by OT-based inventory, because for a variety of vendors, we always check for the current product lifecycle stage and then match that automatically against your installed base. So therefore, you will see, okay, this product is active, no need to worry right now. Then we have the serial number, we have the CPE, that's for the vulnerability management, and I will address that in the upcoming webinar on vulnerability management in much more detail. We have the, what is that? The catalog description, controller, control logics, blah, 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 how much memory, and so on. And where does this come from? Well, it also comes from vendor data that we are pulling automatically and associated automatically with your installed base. Then you even have the vendor link to the product catalog website, so you can go there directly, and this is also inserted automatically by OT-base. Next section here, you have the full display of the backplane of the rack architecture, the hardware configuration, where you can see all the additional I/O modules that are installed here, along with make and model, firmware version, serial number, and also their catalog description. All of that is inserted automatically by OT-base. So again, so far, the only items that you had to add manually was the location of the device and hopefully the description, like what the function of this device is. And basically that's it. If you want to get fancy, then you can add a floor map as you have seen it, but that's basically it. So far, everything else added automatically by OT-base. The other thing I want you to focus on is here in the firmware column, you see that several firmware versions are exposed in orange, and that tells us, well, you know, that's not really the current firmware version. You would see what the current firmware version is by hovering over that entry, and then OT-base tells you, well, for this device, it's actually version 2.13 and you're running version 2.12. Again, that's automatically discovered by OT-base because this is one of the items that we pulled from the vendors' websites. So let's go to the connectivity. This tells us about the network associations. This is the immediate network neighborhood. If I want to see more, I can always drill down. This is the device that is connected to directly. And let's just say I want to learn more about that network. IP address, L2 address automatically discovered, counterpart automatically discovered, but show me the damn network. Then you just click on that entry right here. And you also get a location for that network. Where is that thing? Then you get the IP address list of that network. And you also get the topology diagram with our device from which we started being automatically highlighted and in focus. And then you can zoom on. Oh, no, this is where this thing is. Everything fully automated. No manual editing, not somebody who has input all the IP addresses and network addresses and associated it with that switch, etc. That is not anything that you would have to do. And so it goes. So you can always do additional drill down. So for example, if I wanted to see more about that switch, I do a double click on that switch, and that tells us then everything we want to know about that particular switch, also with the location and everything. So what else have we got here? We have the firmware version being exposed explicitly with the fact that it's outdated. Let's look at security. This tells us about the known vulnerabilities. It does say 0 here, but that is because this checkbox is active here. By default, we only show known vulnerabilities with known exploits. But if I deselect this checkbox, I see, well, you know, there are actually 8 known vulnerabilities for this device. If I want to see what those are, I can go in there and then see the CVEs that affect this particular rack, this control system rack, and do a deeper dive and consider my options for mitigation. Anything else? No, I don't want to pester you with that. Maybe just one other thing here. For every device, we keep a configuration timeline automatically. And that is important because this way we catch configuration changes automatically. So you remember discovery, that is this piece here, runs autonomously every 24 hours. And therefore, we see, okay, you know, so for example, that there was a change in the firmware version or something, or in the networking. And this is going to be exposed here in that timeline where you can then see details. And it's also going to be exposed in the initial events page when you're going here and see, well, you know, show me all those changes, all the devices that had configuration changes over the last 7 days or 24 hours. Okay, so let's go back to the inventory. Let me show you what a Windows PC looks like. And as you guess already, we don't discover just PLCs, network switches, and so on. We also discover Windows PCs with their full configuration. So in this case, we also see the location for that device, and we see the hardware vendor. In this case, is virtualized. Then we see the connectivity, and we see the installed software. Starting with the operating system version, well, I'm pointed to the fact that Windows 7 is end of support. Again, this is done automatically. All the applications that are installed on this box are highlighted along with the version and installation date. And once more, this level of detail is mandatory, absolutely mandatory if you want to do any type of useful vulnerability management, because all the CVEs are associated with specific product versions. That means you could have a known vulnerability that affects a specific version of Factory Talk, Asset Centra as an example, but it does not affect newer versions. And therefore, you need to know what those versions are. The other thing that I would like to point out here, we also have identified all the installed patches on this box. And this is also super important for the vulnerability management, because this way we can also tell you, well, that there is a vulnerability that principally affects this particular configuration, but you don't need to worry about it because it's patched already. So all this level of detail is absolutely fundamental if you want to do any meaningful vulnerability management. Then for the security part here, you will see many more vulnerabilities as compared to the PLC that I showed you earlier. And the other thing that you see here is a graphical representation of the patch efforts, which in this case looks pretty meager, right? So we have a total number of installed patches of 204. This is nothing for a Windows PC. And the last installation was somewhere 5 years ago. So you see that right away. And for the vulnerabilities, here we have a bunch of known vulnerabilities that come with known exploits. Therefore, they're all highlighted in orange. And if I deselect this checkbox, you remember that's for the filter to only show you vulnerabilities with known exploits, and then the number jumps to a much higher value, which it's going to take a while because it's several thousand in this case. So this is going to give you a lot of headache. A Windows PC that looks like this. What else do we have? Compliance section. You can define software configurations that you say, well, this is mandatory for our company, for example, for an engineering station. You can also define software products that must not be installed. We did that here as an example for Adobe Flash Player. And then you will automatically see, well, this box here is non-compliant because there is this Adobe Flash Player running that is prohibited in our organization. So that would require additional manual labor to actually define such a policy. But once that you have done that, it will be used against whatever device you tell OT base to use it against. And so, for example, in this case, against all those Windows PCs. Okay, by the way, I would imagine that in the meantime, you have a bunch of questions. Please put them in the chat and we will address your questions when I've finished my walkthrough here of OT base inventory. So I think that gives you an idea of all the things that can be discovered and inventoried automatically. So it's really not that difficult from a technical perspective if you want to end up with a accurate, comprehensive, up-to-date OT inventory. And yeah, this is how it looks like. So for just to give you an idea, if you wonder what all those colors mean, what do they stand for? They reflect the different device types. So as an example, all the actuators, they are color coded in red, just to make them stand out, and all the network gear is color coded in gray. So you will see that if I would filter for actuators, then everything shows up in red. Okay, so the other thing I would like to highlight here is if we go back to the architecture, that you do have several opportunities for integration and also for exporting the data once that they are in OT-based inventories. You can certainly export to Excel, and you can actually do that just with one click of the mouse, because as you see here, there is a specific button. So for any page, for any result page that you're looking at, when you say, oh, I really want to have this as an Excel table and pass this to Bob, then you just need to click that button, and what you see here in this table will be moved into an Excel sheet that you can then share with others if you fancy Excel still at this point in time. And you could also export data to enterprise IT applications such as ServiceNow, Splunk, or Power BI if you want to do fancy analytics, fancy visualizations. Power BI would be the weapon of choice in this case. We have a standard connector for that, very easy integration where you can then go really fancy with your visualizations and also merge that with other metadata that you may have. You can link to custom apps because OT-based inventory offers you a very flexible and powerful REST API. So pretty much all that you have seen, all the asset information that you have seen in OT-based inventory can be pulled out via the REST API, and you can also push additional metadata into OT-based inventory using that same REST API. So that is basically it for this brief walkthrough how to build an automated OT asset inventory. And with that, I would like to finish this kind of demo, if you will, with the suggestion that you consider downloading this application, OT-based discovery, from our website for free. and just check it out. If you are hesitant, well, I've heard so many bad things about OT-based or about active discovery, how dangerous it would be. Well, you just do it in a test bed or just do it during scheduled downtime. And I promise you, you will be surprised, not just by the speed, like you have all the accurate data within a couple of minutes, but also about all the level of detail that you're going to see without having to send out somebody to physically walk down and go through those control system cabinets or launch an ARP request. I mean, come on, it's 2023, and this just doesn't cut it anymore. It's not sufficient to just have a list with IP addresses and MAC addresses. You need to do better than that. So download this evaluation version that we offer. If you are interested to learn more about the product itself, let me remind you that the full product documentation is online, publicly available. So you will be able to go to the documentation. If you just go to our homepage, and then in the upper right corner in the menu, you will see the link to the documentation, and you will also see a link to our YouTube channel where you have a bunch of videos that highlight different parts of the product. And with that, we will check if we have some questions. Here, go to the Q&A.
Yeah, absolutely. So I think the first question that we should address is, are there recommendations to configure devices to be discovered?
I don't fully understand the question, I would think, but I answer based on the hunch that I'm getting here. To configure any device to be discovery, well, you will need certainly a host where you can install OT-based discovery, and that host must be a Windows PC. You cannot use it, or you cannot install it and run it on a different platform. However, that does not mean that you would need to have a Windows PC in every single subnet that you want to discover, because you can also remotely discover using routing. So if you can route into remote subnets, you can actually do that without having to install additional OT-based discovery nodes in those remote subnets. What else do we have?
So is there a correlation between the devices found and the CVE and patches presented?
If I only see items that actually pertain to devices discovered. It's often a weak point in this. Well, I do have to say first, you have an interesting nickname there, Old Fart. But to get to your question, you will certainly see a lot more CVEs for Windows PCs than for automation devices. Yeah, but that's one part of the answer. The other part of the answer is you will see all the vulnerabilities for your automation gear. So if there is a CVE for your PLC, for your VFD, you will see it in OT-base. So the process of matching CVE against a device that's absolutely identical, no matter if you're looking at automation gear or if you're looking at Windows PCs. The major difference is that for Windows PCs, you will be seeing so much more CVEs for a very simple reason. Well, first of all, a Windows PC runs, let's just say, a couple of hundred different applications and also an operating system that comes with its own plethora of vulnerabilities. Whereas as a PLC, on the other hand, or a VFD, if you will, only runs one specific firmware version, right? So that's a very important difference here. And therefore, you will see many more CVEs for Windows PCs. And what makes matters worse in OT is the simple fact that the fleet is outdated. So you know that you will frequently see Windows PCs there that run obsolete operating system versions. And also when you look at the installed applications, well, they're oftentimes pretty outdated and hence also come with a bigger share of known vulnerabilities. So that is the difference when it comes to real life. But in principle, there is no difference for the vulnerability matching if it comes to a Windows PC or, let's just say, an industrial drive. That's the same process, and you will see your CVEs for your automation gear.
One final question. We show kind of a configuration timeline. How do people use that information?
This is okay. No, you cannot use it to restore a configuration, but it basically only tells you, well, let me give you an example. What you would see frequently, well, there was a new firmware version installed on that network switch or on that VFD. That is what you will see frequently. Certainly, you will not, or you would not expect that OT base would be capable of restoring the old firmware version on your VFD, as an example. That would be bad if that would even be possible. Right? But certainly you can use that information to go back to that previous state. However, I have a hunch that you are onto something more interesting and more important. What you can do in OT base, and let's go back to my screen. Let's go back. So I have a hunch what you are up to. So what I've shown you so far, guys, come on. I've just scratched the surface. There's so much more. And one of these things is the systems part of the inventory, where now we are talking about OT systems, like a conversion line, okay? And in an OT system, you simply tell OT base, well, this is all the automation gear that is part of this particular assembly line or whatever it might be. And then you will get consolidated information with the consolidated network topology for that assembly line. You will get all the networks. You will get a port list that you can expand here. But now let's get to the interesting piece here. Once that you have associated automation gear with a system, it also comes with a release management. So what you can do is, in this list right here, the configuration as it is, you can approve this configuration. And if you have the authorization to do so. And once that you have done that, OT base will automatically inform you about any deviations from that approved configuration. And that might be updated firmware, which, as engineers know, happens frequently. Some contractor comes on site, and while they're doing their stuff, they think, oh, well, actually, since we're here, we can also update the firmware without necessarily informing the asset owner. And this has created and will create problems. And you would notice that right away, because OT base will tell you so. It will also tell you in that events page that I mentioned earlier. So changed systems, you will see that exposed here. There were a couple of changes here. And if you want to, you can even have that sent to your email account as a notification with an PDF that exposes all those changes. I think that's what you might have been after. And that is obviously a very useful feature for maintaining configuration integrity for those systems.
Awesome. So I do want to remind everybody about our upcoming vulnerability management masterclass on the 21st of June. So here in a couple of weeks, I did include a link to register in the comments section. So head over to the website, get registered. I also included a link to the OT base download. So go ahead and go to the homepage and download the latest version there. With that, thank you for joining us.
And we also saved you 10 minutes of your time. How cool is that? Bye-bye, guys.